Hello, welcome to Tiny House and Offgrid Resources. Today is my birthday and we're going to be making a machine that makes free diesel. Well, today's not my birthday, not today, the day you're watching this, the day I made this video is my birthday and we're going to make some free diesel. Okay, so, it's going to be a series of videos. There will be 4 or 5. I'm going to keep them as short as I can. This one, because it's the intro, will be a little bit longer than the others. I'm going to get straight into it, out to the shed in a few minutes, but I just want to give you a little background. Pyrolysis and fractional distillation are two processes that happen within the same machine, and they create diesel from waste plastic. We can create 1 litre of diesel from 1 kg of plastic with a small amount of residue. That residue is a gas, and that gas gets brought round in the cycle and gets used to assist in the powering of the machine. So that means that there are no emissions, there is no waste, there is no pollution. This is high quality, sulfur free, automotive grade diesel that you can make for yourself. During this series of videos, we're going to be showing you exactly how it's done. We're going to start off today with the burner nozzle. This is the very first part of the process. It's what creates the heat to cook the plastic. So we're going to start there, then we're going to build the machine around it, and we'll end up with a machine that's the size of a large family fridge freezer that can be run on a daily basis. It could be run all day and all night if that's what you want, because it will give you free heat and can also heat water for your home while it's making free diesel from free fuel. So without further ado, I'm going out to the shed. Come with me, let's get started. These are the main components of the burner. The burner burns waste oil, which is injected in a fine mist and burns absolutely cleanly with no smoke, soot or residue whatsoever. It's an intensely hot flame and it's used in other industrial applications. The burner design is called a Babington burner, and I'll be making this one out of bits that I've had lying around plus a few parts that I've bought. In my small town, components for this kind of work are a little bit expensive, so it's cost me around $70 for some of the parts that I didn't already have. Unfortunately, the only bits I had were the small piece of wire down the bottom here, which I'll explain the use of that later, an old MIG welding contact tip, a piece of 2-inch galvanized pipe, an airline fitting, and a piece of 1/4-inch galvanized pipe. So these components are going to be assembled shortly into something that you'll recognize as a compressed air powered spray gun. It's going to spray and atomize the waste oil and blow it into the furnace. It will maintain its own ignition because this pipe here remains red hot all the time and perpetuates a continuous cycle. These components here are the oil feed components. Here's a tail barb. This comes in from a gravity fed oil tank which is mounted at about head height. A valve so that you can turn it on and off. This is just a short connector. It needs to be of a reasonable length so we don't transfer too much heat, because this area is going to get very hot. So we want to be able to not burn out the nylon ball inside the valve here, or melt the plastic pipe that's going to connect onto here. This tiny little wire pin that I mentioned before, that is going to be dropped inside this 3/8 to 1/4-inch reducer. I'll explain why shortly. This on the second row here, we've got the air injection parts. Here's an airline fitting to connect it to a controlled airflow through a regulator from my compressor to allow me to connect it to this piece of 1/4-inch pipe. another connector which allows me to go down to a blanking plug. The blanking plug shortly will be drilled and tapped to take the MIG welding contact tip, which has a tiny 0.6 of a millimeter hole. The reason I'm using these tips is because they're interchangeable from 0.6 to 0.8 to 0.9 to 1 millimeter. So I have an easy, cheap range of jetting. On this top row, these are the components that are forming the body of the burner, and these will allow the ambient air to mix with the small amount of air that gets forced through from the compressor and deliver it with the fuel into the combustion chamber to do the heating. Just roughly, here's how they all fit together. The blanking plug goes into the T-piece, but before it goes in, it will have a 1/2 inch hole drilled through here so that this assembly can slide through it. To lock it in place, I'll be drilling another hole and tapping it with a thread just here so that a small bolt can lock this tube in place. That will allow me to control the depth of this into the body of here, because I may want to adjust it. This will allow me that adjustment. So this is going on here. This one will go in here. Now this is the afterburner. This is going to heat up to red hot and will perpetuate the combustion. The airline components, I'll just lightly connect those so that you can see how all this is going to go. These components are assembled just as they were sitting. I haven't drilled a hole in here yet, so you can't see how that will attach, but that will thread in there and be interchangeable with other nozzles. Here we've got the oil delivery system. The oil can be waste engine motor oil, or it can be fish and chip cooking oil. That's gravity fed from a container above. Now, this piece of wire that I was mentioning, I found in earlier models of this that if I just drip the oil through this hole into the body of the burner, it tends to run down the outside of the tube rather than drip exactly over the nozzle, which is where I need it to go. So I came up with the idea of a small pin of metal that just gets dropped in here, and that will encourage the driplets of oil to fall exactly down the pin and drop exactly where I need them to drop. Okay, so that is assembled into here. This assembly then gets a hole drilled right here, and that is threaded in. So this sits here like that. You might remember a few minutes ago I mentioned drilling a hole in the back of this plug with a locking bolt. That's so that this rod can go into here. And the important thing that we're trying to achieve is the perfect relationship between these two pipes. That's why we need that small amount of adjustment for fine tuning. Ambient air is drawn through here, that mixes with the vapors, it ignites in the tube, and we end up with a massive 3-foot long super hot flame out of the end of the nozzle. That gets buried inside the firebox, and that'll be the subject of the next video. Now I'm about to drill the hole for the 1/2 inch to 1/4 inch adapter. We're going to do 2 of these because another alternative fuel source will be the gas from the machine itself. That is a byproduct of the distillation that's a byproduct of the distillation process. So we'll be putting 2 holes, one here and one here, so that both sources of fuel can be injected at these points. Now these taps that I'm using are all different. Every type of thread, whether it's American or Japanese metric or English, all of these threads have a different pitch and a different diameter and even a different thread angle sometimes. So a good engineer has a massive collection of taps. Normally they're kept in a box and are easy to identify because of the slot they sit in. Mine are all just in an old tobacco tin, so it takes me a while to sort them. Anyway, this is called BSP thread. BSP is British Standard Pipe, and we're going to tap a BSP thread into this hole so that we can mount the reducer nipple. When you start a tap, you must make absolutely sure that it's perpendicular on both axes so that you get a nice straight fitting. once you've got it a couple of turns in, it will find its own way. This isn't run-of-the-mill DIY stuff. This is bordering on light engineering. Not everybody's got this gear, but then not everybody's building fractional distillation and pyrolising units. Because these fittings are made out of cast iron, they don't require any lubricant. Cast iron is one of the metals that doesn't require a lubricant for drilling or tapping. Brass is another one, although brass gets an annoying squeak going without lubrication. Doesn't seem to damage the drill, but if you put a little bit of light oil on it, it's easier on the ears. Okay, that's our two ports for fuel created. Now here's the small pin that I mentioned earlier. That pin gets dropped inside there and forms an axis for the oil to find its way and now we've got the jet nozzle comes through here. We screw this into the back. Okay, in this shot you can see the relationship between the oil feed at the top, which is dripping off the small pin, and the air jet, which is located in the center. That can be adjusted this way or that way to achieve maximum efficiency, and then once that's found, we lock it in place and the burner's ready to go. Ambient air is drawn in around and forced down into the burner. Right, here we've got the assembled burner. I've put it onto a temporary base just so that it can stand and shoot flames on the ground while I test it. Later on that will be cut off and I'll put the mounting directly into the heating chamber of the unit. But starting at this end, we've got an air fitting for an air line from a regulated source. That's providing the air down to the tunable jet, which you can see inside is made from a MIG welding contact tip. Above that, we've got the oil entry point, which is a drip feed, so therefore this thing must be always operated this way up. Remember, it's got that piece of wire that creates the drip exactly in the right place for the air torrents to carry it out and into the flame tube. We can control the air at the compressor, we can control the oil flow at the tap here, and we can fine tune by adjusting this nut here and sliding this nozzle tube in and out. I've got it supported at the back here on a rail to provide me with some adjustability, and the whole thing has come in at around $80, and it's actually going to be one of the, well, I think it will be the most expensive part of the unit. So that's out of the way. Let's get it outside, get some testing done. The piece I just filmed was filmed in blustery wind, that's why the flame was shaking around so much. So I'm looking forward to getting this thing inside the burn chamber and showing you some more results. But if this video's been useful to you, please hit the like button down below. You didn't do it. Hit the like button down below. And you can also subscribe to the channel, because coming up in the next few weeks I'm going to be having another 4 to 5 videos documenting the building of this machine, and from then on we'll be going into videos showing it producing diesel. So thanks for your time, thanks for coming along and watching once again. Don't forget, subscribe to Tiny House Offgrid Resources. Have a great day. Bye.